Hello and welcome to this episode of T-Tech. This is part 3 of 3 in our NetBSD Firewall series. I do hope you enjoy it, and let's get into it. Okay, welcome back. So this is part 3 of 3 in our NetBSD Firewall series, and in this part we're finally going to verify that everything we have done is working how it should. So we have a client here on the left. He's connected into the LAN of our NetBSD firewall. So he's connected to that LAN interface. So the first thing we're going to do is go on the firewall, and we're going to introduce a Swiss Army knife of network tools. We're going to run TCP dump space, and then we're going to give switches. We're going to do hyphen. That specifies we want to give a switch, and we want to use N. This disables DNS domain name resolution. So we'll look up the domain name of IP addresses. I'm sorry, it won't find the domain name, the IP address of it, and it will not find the port number. It won't say like port 80 is HTTP, things like that. But if you want that, just leave the N off there. Okay, the I is the interface, and for our interface, we're going to start on our LAN side. So it's WM0. We hit enter on that. You don't see anything yet, but you will. So on this machine, if we do ifconfig WM0, the address it got is 192.168.1.100, and it got that because of our DHCP server we configured. If I do a netstat -rn to look at the routing table, and if I say -f for init, it only looks at the IPv4 routing table. The default gateway is 192.168.1.1. Now, what I'm going to start with is pinging that gateway. So I'm going to ping the gateway. Okay? If we come back over to the firewall, we see that we were able to see that here, this is the source at layer 3, the source IP address, which is our client. This is the destination, which is the IP address of the WM0 interface. It's an echo request, and here is its echo reply coming back from our firewall to the client. So because we don't have a firewall in place, that's allowing the reply to go back. At least we don't have rules on that interface, I should say. Okay, the next thing we'll do, just so you're aware of the ability to do this, if you put an E on there, you will get the Ethernet frames, you'll get the MAC addresses, the header information for the frame. So just make sure the I is the last switch. Just so we know it can do all this for us. And basically, this is here, because it's an Ethernet network, this is what ARP is getting, the ARP requests and replies. And in IPv6, it's a neighbor discovery protocol that does this, which uses ICMPv6. So you would see that if you were looking for that. It would show you either. So let's now go and ping Google. So we're going to ping Google. Actually, let me open that back up on the, let's take out the MAC addresses. Okay. If we ping Google, this here is still the same source, okay? It's an echo request, but where it's going is different at layer 3. It's going to Google's IP. And then you can see Google replied because they're not filtering ICMP echo requests and replies. So if we do the same thing, but we want to now look at our WAN interface side. Whoop, apologize for that. Let's filter by ICMP. So at the end of that, you can filter for yourself. If we ping again, now the source is 192.168.0.25. The reason it is because of the NAT rule we put in pf.conf. So that's telling it rewrite the source address to the IP address on the interface we specified. So it still goes out to Google, but it's just sourced from the IP of our NetBSD's WAN side, and it still comes back. But this is where it changes. When we change the source, when it's going out to the WAN address, the source address field, so the source IP address, that is source NAT. Okay, so SNAT. When it comes back, it does something called destination NAT, because what's happening is it's changing 192.168.0.25 to be 192.168.1.100. All right. So if we do one more to make a little bit of traffic, it's easier to do that and then show you pfctl-ss. Okay. And if you look here, that's the source before it gets translated. And then after it gets translated here, the 192.168.0.25, that's the translation taking place, the source NAT. And then it goes to the destination, unchanged. And when it comes back, it just reverses this process. So you would actually see 192.168.0.25 as a destination, etc. So it's just the opposite. Okay, the last thing we'll do is we'll do some TCP traffic. And the reason is I want you to see that it changes the port number as well, but we need something that will connect for a little bit longer, so I have time to show you. Okay, the O means just don't save it anywhere. The dev null just is nothing, but that's okay for what we're doing. You don't need to focus on that. Cachefly.net, and they have test files. That's what we're going to use. So we're going to hit enter, and real quick, I may have to redo this, but we'll do the TCP dump again on WM0, filter for TCP. And what I want to quick show you, we're going to do a snippet of that output, is the source in the source port, and then the destination, and the destination port is 80 at layer 4. Now keep this source port in mind, because what we'll see if we change it to the WAN interface and do the same thing. Now if we look, when it's going out here, it's hard to show you because it didn't show you the, we'll do this, don't worry about these filters. We'll do that for you. Okay, what I want to show you is this is the connection going out to the server on the WAN side of NetBSD from our client over here on the right, on the left. So the source port is 57850. All right, and it changed. Let's see if I can scroll up. It changed from 65,535. Okay, so that is verifying that everything is working. I showed you a little bit about the state table. The PF state table holds both NAT translations, so it knows how to rewrite them when they come back, and it holds the stateful information about connections. So the connection doesn't have to be natted to create state. It just has to match a pass rule. All right, simple as that. So with all that, I do hope you really enjoyed this series on using NetBSD as a firewall. So with all that, I'm Tyler with T-Tech. Thank you for viewing and have a very nice day.